So hello guys, what's up? Hi ma'am, maing udto ng punta depende po sa ginatan na. So, ang lesson for today is lesson 5.2 Centripetal Acceleration by me and Lay Lover Malaga. So, introduction. So, the second law of motion states that an accelerating object must be experiencing a net force that is in the same direction as the acceleration. So, for something that is moving a circular path, an inward force is necessary to cause an inward acceleration. So, ang inward force daw is necessary for what? Inward po yung acceleration. Opposite siya, no? Outward po. Ang yung force, suppose inward yung acceleration. Okay, so you have learned from the previous lesson that this force is called centripetal force for objects that in uniform circular motion. The moon, for instance, an inward acceleration is needed to maintain the motion around a curvature, like the moon's orbit around the Earth. In this lesson, we will take a closer look at the physics behind centripetal force and centripetal acceleration. Yes. Okay, padayon. So, pasensya kayo. Bungol ang mic mo. Sorry, yung tool. So, centripetal force, I mean acceleration. Recall that since the acceleration at any given point of an object traversing a circular path with constant speed is along the circle's radius and directed towards the center. So, di ba, ang centripetal acceleration, di ba, ano siya dari is any given point of an object traversing a circular path with constant speed is along the circle's radiation and directed towards the center. So, imagine na lang, magbutang ka o ka ng circle, tapos ituyok mo siya. Diba, pag lalo mo siya, tuyok siya, tapos pababa, mas siya sa middle. Yan na siya ma-stop. So, uniform circular motion is also called a centripetal acceleration. Okay. So, centripetal force. Saan na po ng centripetal force? So, think of a can being spun mid-air on its end from a string. This string transfers what we refer as centripetal force to tug the can into circular path. Okay. So, centripetal force derived from the Greek terms which literally means seeking the center. So, kung saan man ang best example, so, i-visualize na to na ang can is nabitay siya, tapos may string. So, pag ituyok na to ang string, di ba mo, circular path po na siya. So, ang string diya mga ginatawag na to nga centripetal force. So, kaning term is given sa Greek, na ginatawag na seeking the center. Refers to a force that is directed toward a fixed focal point. The factors that affect centripetal force include the radius of the circular path or curvature, the mass also, and the tangential speed of the object. And their relation is mathematically expressed as follows. So makita ninyo sa baba nga, force equals to OM mass velocity times squared over radius. So where F is the centripetal force acting on the object, M is the object's mass, V is the object's tangential speed, and R is for radius of the circular path. So, magnitude of the acceleration. So, in lesson 1, we have established that any object traveling around a circular path at constant speed experiences uniform circular motion. So, last time, so lesson 1, any object na mag-travel siya around or circular with the constant circular po niya speed, na siya uniform circular motion. Hindi tayo lang, pero sapat naman guys. The velocity stays constant, but its direction changes as the object traverses its path. So, na may makita diya ang image, figure 5.2.2. As you can see, that is change in velocity for an object moving a distance. It's quite like, medyo challenging siya and medyo complicated, pero trust me, dali na kayo na. So, consider an object with constant speed traveling a curvature with radius R and center O as shown in figure 5.2.2. In a given duration of time, which is ang t, the object has moved from point 1 to point 2 and undergoes a change in velocity. In the process, observe how V1, so makita ninyo dira ang V1 na forms a 90-degree angle with OP1. So dira makita na jud ninyo like as in, causing the angles in triangle and theta to be the same. Thus, kaning formula makita ninyo is the average acceleration during this time interval becomes this. So, change siya. So, in some instances, interval is very short, therefore making the limit
Kining angle na,
like S over triangle na ng P.
actually I don't know what is this. Pero, okay. Become the speed of V2.
At P1, since P1 can represent any given point in the curvature,
We can simply let velocity,
denote the speed of an object at any given point. The process shows how the general equation for the magnitude of acceleration of an object uniform circular acceleration is.
right. The acceleration,
Kining
A, tapos may rad. Piliin ako ang V.
ang A kasi yung acceleration is
So becomes equal
to the square of the velocity v divided by the radius.
of the circular path.
The direction is perpendicular to the velocity and directed toward the circle center.
Okay. So makita ninyo dira as
Sa equation 5.2.2.
Where
A tapos may acceleration tapos radius
is magnitude of
acceleration. So kanina ang A tapos may D na siya acceleration
it is the magnitude
of acceleration of an object in uniform circular motion. V is the speed of the object while R is the radius of the circular path created by the object.
So mo na siya guys. Okay. Furthermore,
Frequency, which is ang F, is or the number of revolutions in a unit of time, and period slash time or kanang P is the amount of time that the object has taken to complete its trip.
in the curvature may also be considered.
Okay, so ang F muna siya ang pila ka revolutions or pila ka tuyukan in the unit of time. However, ang period or ang time muna yung na-consume siyang pagtuyok before nag-stop. Ano ba?
For an object that has
Revolved with a frequency of 2
revs/s,
revolutions slash second. Each
revolution has taken
in 1/2 of a second. Thus, frequency and time are related by P equals 1 over S.
so recall that the magnitude
Of acceleration or A tapos ang red sa baba of an object moving in a circular motion and in relation to time
E is given by kita niyo,
as equation 5.2.3
magnitude of
acceleration equals to 4 pi squared tapos radius over time kaning apila ni ang frequency and time.
time squared.
So where the magnitude of the acceleration in a circular motion, R is the radius and T is the period of motion. So proceed na ta sa example that will be reported by my partner.
So the first example is, consider a planet that has a radius of 4.5 times 10 to the power of 6 meters and in which each day lasts 120,000 seconds. What will be the centripetal acceleration of an object found on the planet's surface right on the equator? So first, ang ipangita diri kay ang centripetal acceleration sa object nga naa sa planet's equator. Second is atong isulat ang given, which is ang radius na 4.5 times 10 to the power of 6 meters and ang time na 120,000 seconds. Next is atong isolve gamit ang formula nga centripetal acceleration times 4 pi squared times radius over time squared. So dire atong i-substitute ang mga given. So 4 pi squared times ang radius nga 4.5 x 10 to the power of 6 meters over ang time na 120,000 seconds square. So ato anang i-solve. Amo gawas kay 1.233700055 x 10 negative 8. Ana, di maklaro wala na wala man pud siya napakita sa paper kung giun sa siya, so tagna na nako kung giun sa pagkuha atong answer nga na given sa paper. So kani ang negative 8 kuan ako siya sa 8 to para to. Ay. Kuan ako siya sa 6. So kung i-minus ni siya, minus siyang 10 negative 2. And dali sila to balik 7 8 2 1. Sa akong nakuan sa atong previous na lesson, pag negative siya kay pa left jud siya. So pag positive naman is pa right. And then mao to akong gi-move diri so 1 2 kay negative 2 man, so naay dot. So ang tapad sa 1 is naay 0, madugang og 0, and ang before sa dot kay naapoy 0. So ang atong answer ani kay 0.0123 meter per second square. So mao na ni. Dili ko sure kung tama ba to, ma'am. Pero mao to na sa paper. Ako lang gitanaw. So, ang second example, a race car has a centripetal acceleration of 9.6 meter per second square. If it is traveling at a constant speed of 42 meter per second, what is the radius of the curvature of its path? So, ang sa problem, ang ipangita dali kay ang radius sa curvature And then, ang given dali kay ang centripetal acceleration nga 9.6 meter per second square ug ang speed nga 42 meter per second. So, dali natay formula ang katong centripetal acceleration equals speed squared over radius or divided by radius. Since ang ipangita man nato dira kay ang radius, i-derive nato tong equation ay tong formula. So, ang magawas kay radius equals to speed squared over centripetal acceleration. Next is atong i-substitute. So, r radius equals to ang speed nga 42 meter per second squared over ang centripetal acceleration nga 9.6 meter per second. So, ato ani i-solve ang 42 squared over 9.6. Pwede naman manuhon, pwede na pud siya diretsoon. So, ang magawas ana nga answer is radius equals to 183.75 meter. So, mao na ang radius sa curvature. Since dili man siya ma-squared kay imo mang i-cancel. Imo i-cancel kay imo mang i-divide. Mo to. Ano to? So, ang last example is a 125 grams ball attached on the strings and uniformly revolves in a horizontal circle if the radius of its curvature is 0.550 meters and it makes 2.50 revolutions per second. What is its centripetal acceleration? So, identify what is required in the problem. So, you are asked to calculate the centripetal acceleration of the ball. So, first, kay, ang given nato dali kay ang radius of the circular path na 0.550 meters and the rotational speed nga 2.50 revolutions per second are given. So first is to determine the tangential speed of the ball. To do this, convert 2.50 revolution per second to rad per second. So, itong formula dali kay kani. Times. Itong convert na to nga revolution which is 2.50 revolution per second times 2 pi rad per 1 rev. So, kung isolve na to ni kay amo gawas kay 15.71 rad per second. Since kuan lang man, thousands place. Kumaan kay i-substitute na to siya para makuha na to ang tangential speed. Mao nga formula Vt equals to Rw. So, para makuha na kaya 550 meters times nimo sa katong total kaganiha nga 15.71 rad over seconds. Ang magawas ana kaya 641 meter per second. So, nakita na to ang tangential speed niya. Next is ato na siyang gamiton sa centripetal acceleration. Ang formula kay mao man ang gipangita jud. So, kay ang pangita man kay centripetal acceleration ana. Then ang naa lang sa ato ang akuan kay ang speed squared o ang radius. Ay mao man ata. Ang speed katong answer atong last na to nga gi-solve which is 8.641 meter per second squared over our radius na 0.550 meters. So, kung ito lang isolve, ang mugawas kay 135.76 meter per second. So, mao na ni ang second square, mao na ni ang centripetal acceleration sa example 3.